All right, here we are. Thank you so much again for having me. My name is Andreas Grabner, but please call me Andy if you ever see me or if you address me Andy, the short version. You can see it, I think, on my little window in my video. Today's topic is don't deploy into the dark, DORA metrics for Kubernetes, also known as observability and orchestration of your deployments. I will be talking about a CNCF project that I'm very active in. It's called Captain. Just a couple of words to myself. I always say during the day, I work for Dynatrace. We are a software intelligence company. And in the rest of the time, I am on the one side a CNCF ambassador. I was just elected to be one of the new ambassadors for CNCF, for the Cloud Native Computing Foundation. And in this role, I really want to make sure we connect with our community that is interested in everything cloud native. I do have personal interests, obviously. As I said, Captain is a big topic. Another big topic is open feature. Open feature, in case you haven't heard it, it's a way to standardize how development teams can build feature flagging into their applications. What we try to do with open feature is providing kind of like a similar standard on what Open Telemetry has done, how we are collecting observability data. So providing a standard for developers to implement feature flags and also for feature flag management tools to have an open standard how they can manage their feature flags. If you want to catch up with me later on, you can see my Twitter handle @GrabnerAndy. I also am on LinkedIn. And then if you are interested more in Captain, then please free to connect on Twitter as well, and also lifecycle.captain.sh. This is the part of Captain I will be focusing on today a little bit. As I said, this should not be a one-way street. I keep an eye on the chat here. Now, my Polish is limited. In case you're asking a question in Polish, you probably don't get an answer from me. If you're asking in English, that would be great. What I would like to know is, if you're watching this, DORA, is DORA a topic that you're aware of? Are you using DORA already, or is this completely new to you? Second thing is, have you heard about Captain? That would be interesting for me. And the third thing is GitOps something that you do? And if you do GitOps, are you using Argo? Are you using Flux? Just give me a little bit of feedback on what GitOps means for you. But now let's get started. So I want to kick it off with the main topic, and I want to give a little bit of overview for those that are not familiar with DORA. DORA for me is a way to measure the efficiency of your kind of DevOps implementation, if you can call it even an implementation of DevOps that you do, right? Your best practices. DORA isn't nothing that I came up with. It comes from the DevOps Research Institute, and basically there are 4 key metrics that are used to measure the efficiency and also kind of the maturity of an organization as you're applying DevOps best practices, as you are speeding up your deployments and as you're increasing code qualities. These 4 metrics are deployment frequency. That means how often does an organization actually deploy into production? Lead time for change. That's a metric that basically say how long does it take you to get a code change all the way into production? Change failure rate is another interesting one, right? What's the percentage of deployments that fail? Because if you just speed up, but you're always failing, obviously doesn't help you in the end. So change failure rate is a critical metric. And also time to restore service is the 4th metric. It basically says if you have a deployment and it goes wrong, how long does it take you to recover from that problem? In many organizations I talk with, and many DevOps teams and many, I think, platform engineering teams now that are building platforms for internal teams to then build and deploy software with DevOps in mind, these are 4 metrics that are used to really measure if you're successful or not. So I hope this will be useful and interesting for you. Now, there's a big thing that I believe that has changed in the last couple of years, at least that I've been active in the community. If you think back on how we used to deploy and build software, call it the monolithic word for the lack of a much better term, but I think it is a good term. In the times when we built monolithic applications, we had the complexity of building the app and defining what an app is, the app composition all on the development side. That means you had multiple developers, multiple development teams trying to get in their code changes in the shared code repository, and then using, complex CI/CD pipeline tools that was making sure that this code could work together, was tested, security checks were done, was validated, and in the end, what came out of it was, more like a monolithic application that could then be deployed and quote unquote simpler operated, right? Because it's easier to operate and deploy a single monolith on a well-defined infrastructure. And this is kind of also when we look at DORA, if you are implementing DevOps practices and if you measure how often you move from left to right, you basically measure this in the context of an application that you're pushing through, right? And the world has changed, obviously, right? I'm pretty sure many of you are no longer building monolithic apps, but you are already there, or you're moving into the cloud native world, where cloud native doesn't necessarily mean it has to run on the cloud, but it's the way we're building modern applications. It is more componentized. It is, instead of having one big code base, you typically, at least what I see, teams that are building their own services in their own Git repositories, and then using either the tools that they've been familiar with for years. Jenkins is still out there, still a great tool, or they're using more modern GitOps tools like Argo, and then are pushing their individual services from their dev environment closer and all the way into production. But with this shift, we also see, I think, a big complexity, because now the definition of what is an app, which versions of which services belong together to a release, and how do you test the combination of all this? How do you validate security? How do you deal with observability and orchestration? This is something I think that has been pushed towards the operation side, because now the development teams typically focus on building and cranking out as much as possible new features on their services, but figuring out what is the bigger picture, what is the release, what is the app, where does it run, on which services. It seems this complexity is often now shifted towards the right. I like the word right shift of complexity. And if you think about DORA again, if you want to now measure how efficient you are, and if you only measure how often you're building a service and push it out, then you're measuring the wrong thing. Because just because you are speeding up individual service deployments doesn't mean you're actually speeding up the release of a new feature that is then accessible by your end users. And this is also why I think we need to, when we talk about DORA, we need to keep in mind that we need to solve the application composition problem. We need to figure out, what do we measure? Do we measure individual services, or do we still want to measure how long it takes and how often we deploy changes that actually end up in the hands of our users? All right, so just to give you a little bit of background into the complexity. Now, why am I telling you all this? Because I think we have a huge opportunity now with Kubernetes, with the platform, I think, of choice for many of us, and modern tooling around GitOps on how we get stuff from Git into operation. We have a big chance now in getting all the metrics that we need in a very, I would say, sexy way, in a very Kubernetes native way. And this is where Captain comes in. So Captain is the CNCF project, open source. You can download it today and just install it on your clusters. Basically, what we have been doing with Captain, we bring you observability into your Kubernetes cluster, but we're using open source standards. That means you can use any observability tool to get to those metrics, whether it is Grafana, Jaeger, Dynatrace, Lightstep, Honeycomb, Datadog, New Relic, whatever it is, we don't care. So what you need is, if you have a GitOps tools, if you have a Kubernetes cluster, and if you have your observability tool already in place, then the only thing you need to do is you need to install the Captain Lifecycle Toolkit. And I'm highlighting here Lifecycle Captain.sh. The Captain project itself has already been around for about 4 years. And if you go to the general website, you will see Captain, what we call version 1. Last year, we kind of switched over to really solve the problems that we see today. And these are available through the Lifecycle Toolkit. So you install the Captain Lifecycle Toolkit. And then whenever you are making deployment changes, you're pushing out new code changes, you're deploying a new service that is part of an app, then Captain can be told what actually makes the app. So we make your deployments application aware. And every time you are then deploying changes to one or multiple services, then Captain is sitting in Kubernetes. It is intercepting the deployments, but it's actually measuring the deployments. It is measuring the time. It has capabilities to measure the success of a deployment. It has the capability to figure out how many changes happen within an app. And it is then producing both metrics and traces, which means what we give you out of the box is, on the one side, Prometheus metrics about how many deployments happen, how long did it take to do a deployment, how many of them failed, how many of them were successful, when did they happen. Now, because it's Prometheus, you can use it, right? If I go back, you can look at this data, let's say in a Grafana dashboard, if that's what you use. In my day job, I work at Dynatrace. So obviously, Dynatrace is my tool of choice when I look at data. So because we have an open standard, I can look at the same Prometheus data in my tool. What we also do is we not only provide you metrics, because metrics alone in a world where we are deploying very complex applications with a lot of dependencies is no longer good enough from my perspective. We're also providing you an end-to-end trace from the first service that gets changed until the last service as part of that GitOps rollout is out there. So we give you a full end-to-end trace from the first deployment until the application is fully deployed. And we additionally provide some capabilities where you can do pre- and post-deployment checks. So we also automate the way to validate, is your deployment not only good because the pods are healthy, but because your application is accessible, all of your health indicators are good. We can look at SLIs and SLOs and all of this. And we are tracing this whole life cycle of the app. All right, so this is kind of Captain in a nutshell. How does it really work? Captain is a Kubernetes operator. So the Captain Lifecycle Toolkit is an operator. You install it on Kubernetes, and we are leveraging the Kubernetes webhooks, and we are extending the Kubernetes pod scheduler. Why do we do this? So if you have an application that has, let's say, 3 services, front-end, back-end, and storage, then the first thing we do is when we are monitoring and observing your deployments in your namespace, so you can enable Captain on a namespace basis, we first of all measure how long each individual deployment of a workload takes. And we provide this then as metrics. So this is where you get your first metrics based on individual services. What else do? We allow you to define what an application is. Again, Kubernetes itself currently doesn't have the concept of an application. It has a concept of workloads, but not of what an application is. So in Captain, you can define that an application consists of these particular services, front-end, backend, and storage. And if either of those changes, one or multiple, then Captain starts monitoring the time it takes for the first change until the last change is through. What we can also do is, right, we measure the first before everything gets started and at the end when everything is finished. We are, again, creating metrics, but we're also creating traces. Remember, OpenTelemetry is has a great tracing capabilities. That means we can create traces that starts with the first deployment we see that belongs to an app until every single workload has been fully deployed by Kubernetes until everything is finished. Now, you may have wondered, what is this pre- and post-deployment? It's not only a way for me to visualize that these are our measure points, but what we also include in Captain, we allow you to define tasks and evaluations, as we call them. So natively in Kubernetes, you can define that before a deployment happens or after a deployment happens, you want Captain to execute a serverless function to do checks or to query metrics from your environment to validate if the system is healthy or not. I'll give you some examples. As a pre-deployment check, you could, for instance, say, are all of my external dependencies there? So instead of you building this into your pipeline, you can do this natively in Kubernetes because the tasks are also configurable and definable as Kubernetes CRDs. Give another example, post-deployment. You can say post-deployment, when Kubernetes has deployed the pods, you want to run a simple end-to-end test, executing maybe a couple of curl commands to make sure that your APIs work correctly. And after that, you can evaluate and you can reach out to your monitoring tool, the observability, looking at Prometheus metrics, things like, is the application not only running, but is it also performing as expected? We're not running into any memory issues. Everything is fine. There's no critical log messages. So you can use evaluations to validate if the application really runs as expected. All right. So how does this then look like? I want to first of all show you what traces we get and what metrics we get. And by the way, I will show all of this also in my live demo. But if you're making a deployment change, whether it's kubectl apply, whether you're using an Argo or any other tool, basically the Captain Lifecycle operator starts tracing, starts an open telemetry trace that you can look into at Jaeger or any tool that you have, Dynatrace, Datadog. And we automatically, as I said, give you a full end-to-end trace of the first workload that is changed, that is part of that application, until the last workload is done. But not only that, we also show you and visualize how long the pre and the post-deployment tasks and evaluation takes. So if I have a look at this here, right, I can see that the whole deployment of that change of version 301 took about, 2 minutes, something like this in total. The individual pieces are, you can ask Captain before the app gets deployed, please execute some pre-deployment tasks. So for instance, before the app, as I mentioned earlier, are my external dependencies there? Do I have all of my approvals? Is the Kubernetes cluster not under quarantine? You can do all of this natively in Kubernetes and Captain executes it for you. If all of this is good, then Captain allows Kubernetes to actually deploy the workloads. Until then, we're actually holding back the Kubernetes pod scheduler to not allow the scheduling of the pod. But when we allow it, then again, what we do pre-workload checks. We then let the deployment happen, and then we do post checks. So on every single workload, remember earlier the example, front-end, back-end, storage. If you have a complex app like this, for every workload, you can specify your pre and your post actions that should be executed. And we'll do this for 1, 2, 3, how many workloads you have in your application. And then at the very end, once everything is deployed, then we execute the post app. And I think this is a great slide to show you what is happening, what Captain is doing, but also how it visualizes itself in a trace, because this is a trace that you then get for every deployment you make. Folks, I also keep an eye on the chat here. Either my chat is dead, or either technology doesn't work, or you're just very quiet. So if you have a question, please use the chat feature. I keep an eye on it. And do me a favor, English is easier for me. My Polish is limited. German obviously works as well. But that would be great. If you have questions, let me know. So we get the traces, and we also get metrics. As I said, the talk track for me today is talk about DORA metrics. DORA is really a side benefit that we get from the way we are monitoring and the way we are creating traces and everything. And you can look at these metrics automatically just by installing Captain in your Grafana, or as I said, and I work for Dynatrace, in Dynatrace, it doesn't matter. So now, first quick live demo, because I want to make sure that you know that this is not just PowerPoint programming that I'm doing here. All right, so let's walk over to my browser. First of all, if you are interested, lifecycle.captain.sh, this is the part of the Captain project I'm focusing on today. As I said, Captain has been around for a while, but the Lifecycle Toolkit is our way forward from now on, solving the true problems we see in Kubernetes environments for DevOps teams that are building the next generation of platform for the engineers. The demo that I'm showing today, you can run the same demo yourself if you want to. I have it. It's called KLT, stands for Captain Lifecycle Toolkit on K3S with Argo CD. So in my demo, I'm using Argo, I'm using Prometheus, I'm using Grafana, I'm using Slack in my demo environment. You can run all of this yourself. The only thing you need is either you already have a Kubernetes cluster, then you can run a script and it installs everything on your Kubernetes cluster. If not, the only thing you need is a Linux machine, and you can run my script and it then installs a K3S cluster, which is a lightweight Kubernetes cluster. So if you're interested in Captain Sandbox, KLT on K3S, this is the repo. So after you've installed it, one of the things I want to highlight here, right from a DevOps perspective, and we talked about GitOps and we want to get all the metrics, I'm using Argo in my case. So my sample app that I have is very simple because I wanted to keep it simple today. My sample app is a single microservice. I show you how this looks like. This is my app. Not very sexy, but it is currently deployed in build number 2. I have 4 builds available, and I will deploy build number 3 in a second. It changes the behavior a little bit. It has different problems or different performance behavior. But just so you know, this is my current build number 2. And if I go back to Argo, right, if you've never seen Argo, Argo basically shows me the simple node dev. That's the app, and I have earlier deployed version number 1 in my demo, and then version number 2. Oh yeah, that's awesome. My chat is working correctly. You're very clear explaining the subject. Thank you so much. Just want to make sure that nothing goes wrong. And I know we have a little delay here in the chat, but keep it coming. At least now I know we're all good. All right, so if you've seen Argo before, it basically just synchronizes my Git repository where I have specified what I want to deploy and make sure it gets deployed on my Kubernetes cluster. So what I want to do now, we've all seen that version number 2 is deployed. The Git repository behind the scene is this here. So that's my, my own forked version of my demo. And there is in this Git repository, right, there's all the files for setting up the demo, but then there's also the directory, the simple node dev. That's the one where I have my my deployment definition, my ingress, and all of this. So what I'm doing now, I want to show you something. So this is my simple node dev. It's just a regular deployment. The only thing that is different is I have a couple of annotations here, and I will explain this once I go back to the slides to give a little overview. But it basically says, I want this workload to be monitored by Captain. Captain should know that this workload is simple node. This is the version. And then here I can specify my pre and my post tasks. Now, what I want to do is I want to switch from version number 2 to version number 3. I'm doing 2 things. I'm changing the version that I give to Captain, right? I said this is version number 3. And I'm also changing my image here to the latest version, and I say update to version 3.02, commit. Now, this is now the beauty of GitOps. I make the change. If I quickly go back to Argo and I refresh here, I should see Argo is now syncing, right? It basically gets my, hey, there's a change in my Git repository. It's now making the updates. I already see here in the visualization that build number 302 is coming in, or let's say that way, this what you actually see here is that Captain has detected a new workload. So Captain is already active. It is detecting there's a new workload being deployed. You can even now see it's also executing my pre-evaluation and my pre-tasks that I've specified, right? If I go back quickly to my deployment definition, you can see here I have a pre-deployment evaluation. I want to evaluate dependencies, and as a pre-deployment tasks, I also want to execute a so-called notify action or notify task. What notify actually does, just to quickly show you the output, it actually sends me a Slack notification at 4:39. This was about a minute ago. So in a completely declarative way, I basically say, I have a new version of my service that is monitored by Captain. Captain is taking care of executing pre- and post-deployment tasks. But what Captain also does, coming back to the kind of the talk track of today, it also generates metrics, right? It generates not only metrics, but it also gives me traces. So what I have here is my Grafana dashboard. Let me just go to the last 30 minutes. Here we go. In the last 30 minutes, let's see here, version number 3, there was like there's a trace coming in. I can also see when the deployment happened. Now what I can do, I can open up this link in a new tab. And the beauty of this is now I get to see everything that Captain is doing for me, right? The whole end-to-end trace. What is actually happening as my GitOps tool of choice, in my case, Argo, it could also be Flux, it can be any tool, as it asks Kubernetes to please apply the changes. Captain is intercepting this, or not, yeah, intercepting it. And we're automatically creating an end-to-end trace that says what actually happened from the first change that Kubernetes wanted to make until everything is finished. And it also includes the pre and the post deployment actions, because as you're using Captain maybe in the future also for orchestration purposes, for pre-checks, for post-checks, for executing some tests, for notifying people, for scaling up, for scaling down, you also want to know how long that takes, because this becomes part of your end-to-end delivery actions of your life cycle. Right? So this is here. Now, the beauty of it, right, what we do, as you can see, if I go back, Captain is really emitting Prometheus metrics. So if I quickly go in here and change my, you can see here there's like Captain is emitting Prometheus, and I have set up that my Prometheus metrics, accessible here from Grafana. But just so you see here, what is Captain exposing? Some metrics, count total, the duration. These are all metrics that you can get also with different dimensions and labels. So we'll create these metrics per app, per version, and so on, and then you can build nice dashboards, as I've just shown you. And also from a trace perspective, Captain creates open telemetry traces. In my case, if I quickly go to my environment here, right, this is my Kubernetes cluster, and if I do a quick kubectl get pods in the namespace Captain, just to see what I have here, right? So in my Captain namespace, I have my lifecycle operator, right? That's the operator that does all the magic in detecting and watching out for your deployments. I also have my OTel collector in here, because in my sample, I deployed the open telemetry collector in the same namespace. What else do I have here? I have Jaeger here for Jaeger tracing. I also have the metrics operator, which is another thing I will explain in a second, that also comes with Captain. Other things I have, if I do again a kubectl, maybe get pods A, and hopefully this is big enough, friend. I have in my monitoring namespace, as I mentioned in my demo, I've installed Prometheus, Grafana, and the alert manager comes with it. I also run Dynatrace on the side, which means I also get to see the same data, because that's the beauty of open standards and the way Prometheus and open telemetry work. My open telemetry collector is sending data to both, to Grafana as well, to Jaeger, as well as to Dynatrace, and also Prometheus can be scraped by Grafana or Dynatrace. So I have both in there. Let's see, what else do I want to, oh yeah, of course, I have Argo installed as well, right? That's just my CI, my GitOps tool. And then in my simple node dev namespace, this is where you on the one side see the deployment itself, and then you see the pre and post. These are all basically pods that were executed to execute the tasks, but they're already all completed. It's kind of like a serverless function, serverless runtime that we run here. So this is kind of my environment. Let me go back. So I have the data here. As I said, the beauty of open standards is I can have the same data. I do have the same data in Dynatrace, and in this dashboard, I actually get to see how long the deployment took for each individual version that I deployed. So for version 1, it took 1.6 seconds, 1.6 minutes. For my 2, a little less, and version number 3 was deployed super fast, also over time. But in the end, it's the same metrics, right? In the end, behind the scenes, my Dynatrace, for instance, is using the same Captain metrics that come in from Prometheus. So it doesn't really matter which tool you use, whether you're using Prometheus, like Grafana, Datadog, Dynatrace, New Relic, right? You can see your Captain app total count and then split by the status, and you get the same thing. That's the beauty. And also the traces. You saw the trace earlier in Jaeger. So same trace is here in my other tool of choice. Okay, that's the beauty of open standards. You view it wherever you want. All right. So we deployed version number 3. All right, let's see if I refresh the screen here. I think it should probably, what is still, it's all finished now, right? All of the pre and also the post-deployment tasks have all been finished. And we also added some configuration in Argo. In case you use Argo, Captain comes with an extension to the UI, so you actually get to see the actions that Captain is executing. So, but To sum it up, really the only thing you need to do is install Captain Lifecycle Toolkit, and then you deploy however you like. And then Captain automatically gives you the metrics and the traces. So you know how often you deploy, you know how long it takes, and you can execute and define pre and post deployment tasks. So, and to this now a little bit more, because I want to make sure you also understand what it takes, because it takes one more additional step, and this is some of the configuration. So, Captain configuration. What you need to do after you install the Captain operator, you need to enable Captain for a particular namespace. Right? By default, we don't do anything. You need to annotate your namespace with Captain SH Lifecycle Toolkit enabled, and that basically tells our operator that we need to listen to changes in that namespace. Then, and you've seen this before, for your deployments or your stateful sets, you can add annotations that basically tell Captain that this is a deployment within that namespace that you are interested in observing, in orchestrating. Workload and version is mandatory. Pre and post tasks are optional, but they're super useful because you can then specify what should be done pre and post deployment. Also, and I say this optional here, but this is one of the big selling points for me. In my example, I have a single workload, a single microservice. If you have a complex app with multiple services, multiple workloads, you would define a Captain app where you really basically specify what your application is, right? The workloads, in this case, which workloads in which version belong to an app. And then you can also specify pre and post deployment tasks, which is also very important because you can execute something before anything happens to the app and after the app is fully deployed. Now, the next thing I have is tasks. So we allow you to specify tasks. And the cool thing with tasks is you can just specify JavaScript code, TypeScript code actually, where you can then execute you can define any code that is then gets executed as part of a pre or post action. We're using the Dino runtime here, which is a lightweight TypeScript runtime. And in my example, I've basically used this to execute and send over a Slack notification. I'll show you the code in a second. The other thing you can do, you can specify evaluations. We have a long history of site reliability engineering in our team. That means what is very important is that pre and post deployment, I can validate against my observability data whether my environment is currently healthy and also whether it is healthy and the application runs as expected based on my key service level objectives. So you can specify a Captain evaluation where you can define one or multiple objectives. You can reference a so-called Captain metric, and you can give it an evaluation target. So in this case, I specify that the available CPUs need to be bigger than 4. Otherwise, I don't want to deploy, for instance. Or after the deployment, you could do something like the response time of my service that I just deployed needs to be below a certain threshold. Otherwise, you may want to roll it back. One thing to this, it references here a Captain metric, which brings me to another key component that some of our users are now also using. Can it stand alone because it solves a very cool and unique problem as well. The Captain metric server, one metric server to provide metrics for all of your Kubernetes tools. What does this mean? Most of people out there that I've seen, you have one or multiple monitoring tools. You have Prometheus, you have Datadog, you have Dynatrace, you have New Relic, whatever it is. And then you want to use the tools or the metrics from these tools back in some of your native tooling in Kubernetes. Now, what we are doing is we are providing a metric server that is basically solving the problem of bringing all of your metrics, also from your external observability tools, back into Kubernetes so that you can use it for your Argo rollouts, for your auto-scaling, or even for the Captain evaluation. So how does this work? You define a metric provider. You can say, hey, Captain operator, I want to define Prometheus. Here's how you get it. Or it could be Dynatrace or Datadog, and then you give it the endpoints of the API. Then you can specify as many Captain metrics as you want. Remember the available CPUs example? That's the one I had earlier. Specify the query. And then what Captain metric operator really does it does the hard work for you. So in this case, every 10 seconds, it goes to your metric provider, pulls the metric, and then provides it to any tool that needs it. And it does it in a very nice way. It provides it through the Kubernetes Metrics API, which is a standard, which is, for instance, used by CodeFrenzy. We also export just the Prometheus metric, and we also make it available through the CRD, obviously. So let me quickly show you the live the configuration a little bit in more detail. Same example as I had before. If you want to look at this yourself, right? So we had, first of all, the namespace. Remember, if you enable it, you need to just add the annotation that Captain should watch out for that namespace. Then what else do we have here? I talked about the tasks. Now remember, I go into my deployment first. What I said here is a pre-deployment task and as a post-deployment task, I want to call the notify task. So let's see what the notify task does. I have Captain tasks here. My notify task is basically a JavaScript function that gets executed every time for a pre and post deployment of my workload. It gets some context about what workload it is, which application, which version, also some secure data. You can also pass in credentials from external tools, but in a secure way. And in my case, it is really making a call to Slack. I'm just building the Slack message here. Remember from earlier, if I go back, these are the two Slack messages. This is for the pre and this is for the post. And I don't need to build this into any pipeline. It just works automatically because Captain is orchestrating these tasks for me natively from Kubernetes. So that's really nice. Next thing I want to highlight here, metrics. So I got the Captain Prometheus provider, same as I showed you. I basically say, hey, Captain, you can query Prometheus from my local instance. I have in the same cluster. You could obviously point it to wherever you have Prometheus or Dynatrace, Datadog, whatever it is. Then the metrics, same as before, right? Captain metric, give it a name, and then say query it from this provider, and then this is the query, and then how often it should fetch it. Also really nice. And then I can use this metric, in my case, in my evaluation. Here is my evaluation. I have my evaluate dependency, and I have my evaluate deployment. This is the one that I call pre-deployment, and this is I call post-deployment. Now I made it easy here, my sample, I just used the same metric, but you can then query metrics from Prometheus, you can query it from Datadog, from Dynatrace, because maybe these tools have different metrics that you want to use to validate if a deployment was good or not. And so what we do with the Captain Metrics server, we provide a common one metric server that can talk to all of your observability platforms and provide this back through a standard interface. Right? Can be used, as I said, CADA, HPA, whatever you have. And I think that's it from this part. The last thing I want to show you is, right, if I want to go back quickly to my Argo, one of the things that happened in my deployment of 3.0 as part of the post evaluation, right? If I look at the details here, the reason why Captain said this is a good deployment, because it pulled in the available CPUs. The value that came back was 8. And remember, this comes in my case, from my Captain metric server that is pulling the data in from Prometheus. But the same metric can now also be used by CADA or by Argo rollouts or by anything else. Gone are the times with this where you have to configure different metric plugins for every single tool, because every tool needed their own metric integration with a particular tool. With Captain metric server, we want to standardize this. All right, so I have about 2 minutes left, and then I want to go back to wrap it up. What we want to do with the Captain Lifecycle Toolkit, observing and orchestrating the lifecycle of your Kubernetes deployments. I've shown it to you on a single environment, but really, if you think about it, we can not only do this in a single environment, but we can do this from the first Git commit that makes it into a dev stage, all the way into staging, all the way into production. So in the end, we want to use this capability, and you can use it if you want to, for end-to-end traceability and observability and orchestratability of your deployments. All right. So last slide before I hand it back to the team. We want to really make sure that not development teams can not only be autonomous and deploy as often as they like, but we also give the platform teams, the DevOps teams, everything they need to really make sure that it becomes simpler to deploy, observe, and operate these apps, because you can now define them. You have an observability platform. Everything is based on open standards. And this is why we think with Captain, we can contribute to a better DevOps world. All right. And with this, I want to hand it back over to Camilla and the team. And let's see if there's any additional questions. You were a little bit quiet on the chat, I got to say.